Before you came round, I was heading for a small disaster. Before you came round, I was ready to blow me down.
The file system structure is the most basic level of an organization in an operating system. Almost all of the ways an operating system interacts with its users, application, and security model are dependent upon the way it organizes files on storage devices. Providing common file system structures ensures and programs are able to access and write files. File system breaks down into two logical categories: shareable versus unshareable files, variable versus static files. Shareable files are those that can be accessed locally and remote hosts. Unshareable files are only available locally. Variable files such as documents can be changed at any time. Static files such as binaries do not change without any action from the system administrator. The reason for looking at files in this manner is to help correlate the function of the file with the permissions assigned to the directories switchable them. The way in which an operating system and its users interact with a given determines the directory in which it is placed, whether that directory is mounted with read-only or read-write permissions. The level of access each user has to that file. The top level of organization is crucial. Access to the underlying directories can be restricted, or security problems could manifest themselves if from top level down it does not adhere to a rigid structure. Generally, file system can be stored on a secondary device such as hard disk. The file system is generally divided into several layers. So here are the layers we have. The layered file system, application programs, then the logical file system, file organization module, the basic file system, I/O control, and the devices. Next, we have the typical control block. First is the file permissions, file dates, create, access, or write, file owner, group, ACL. Next is file system, file data blocks or pointers to the file blocks.
We have system calls at the API level, but how do we implement their functions? First, on disk, and second is in-memory structures. Boot control block contains if needed by system to boot OS from that volume. Needed if volume contains OS, usually first block of volume. Total number of blocks, number of free blocks, usually first block of volume. Directory structure organizes the files, names, and inode numbers from the master file table. Per file control block or FCB contains many details about the file: inode number, permissions, size, and dates. NFTS stores into in master file table using relational DB structures. In-memory file system structure, mount table, storing file system mounts, mount points, file system types. The following figure illustrates necessary file system structures provided by the operating systems, plus buffers hold data blocks from secondary storage. Open returns a file handle for subsequent use. Data from read eventually copied to specified user process memory address. Partition and mounting. Partition can be a volume containing a file system or ROM, just a sequence of blocks with no file system. Boot block can point to boot volume or bootloader set of blocks that contain enough code to know how to load the kernel from the file system, or a boot management program for multi-OS booting. Root partition contains the OS. Other partitions can hold other OS, other file systems, or BROM. Mounted at boot time, other partitions can mount automatically or manually. Virtual file systems. Virtual file systems or VFS or Unix provide an object-oriented way of implementing file systems. VFS allows the system call interface, the API, to be used for different types of file systems. Separate file system generic operation from implementation details. Implementation can be one of many file systems or network file system that implements vnodes which hold enodes or network file details, then dispatches operation to appropriate file system implementation routines. The API is to the VFS interface rather than any specific type of file system. So first, it will go to file system structure, which contains all the nodes. Then it will go to the VFS interface. Then it will go to 3 stages. First is local file system type 1. And then second is the local file system type 2. And then the last is remote file system type 2. Then for the local file system, it will go to this, and then for remote, it will go to network. For example, Linux has 4 objective types: enode, file, superblock, and then tree. VFS defines set of operation and the objects that must be implemented. Every object has a pointer to a function table. Function table has addresses of routines that function on that object.
So for the directory implementation, there is the number of algorithms by using which the directories can be implemented. However, the selection of an appropriate directory implementation algorithm may significantly affect the performance of the system. So we have the linear list. So in this algorithm, all the files in a directory are maintained as single linked list. Each file contains the pointers to the data blocks which are assigned to it and the next file to the directory. So we have the characteristics. So first is, when a new file is created, then the entire list is checked whether the new file name is matching to an existing file name or not. In case it doesn't exist, the file can be created at the beginning or at the end. Therefore, searching for a unique name is a big concern because traversing the whole list takes time. So second, the list needs to be traversed in case of every operation on the files, therefore the systems become inefficient. So for the table of the linear list, so we have the file name and we have the pointers to data blocks, and there is the file name too, then there is also a pointers to data blocks on linear list. Next is the hash table. To overcome the drawbacks of single linked list implementation of directories, there is an alternative approach that is hash table. This approach suggests to use hash table along with the linked list. A key value pair for each file in the directory gets generated and stored in the hash table. The key can be determined by applying the hash function on the file name, while the key points the corresponding file stored in the directory. So now, searching becomes efficient due to the fact that now, entire list will not be searched on every operating system. Only hash table entries are checked using the key, and if an entry found, then the corresponding file will be fetched using the value. So we have here the table of the linear list. Then there is the file name and the pointers to data blocks. So under the table of linear list, there's the table of the hash. So there will be a key 1, key 2, and key 3. And besides that is the value 1, value 2, and value 3. A linear list is the simplest and easiest directory structure to set up. Unix basis OS uses this in details of files in a directory are stored in a special type of file. This makes deletion and addition easier but search very slow. Sorting the list makes searches faster at the expense of more complex insertion and deletion. So linear list of file names with pointer to the data blocks. So it is simple to program and time-consuming to execute. Next is the hash table, linear list with hash data structure. So it decreases directory search time and the collision situation where two file names hash to the same location. And it is only good if entries are fixed size or use chain overflow method.
For the efficiency and performance, these tend to represent a major bottleneck in system performance, since they are the slowest main component. In this section, we discuss a variety of techniques used to improve the efficiency and performance of secondary storage. For the efficiency, the efficient use of this space depends heavily on the disk allocation and directory algorithms in use. For instance, Unix nodes are pre-allocated on a volume. Even an empty disk has a percentage of its space lost to nodes. However, the pre-allocating the nodes and spreading them across the volume, we improve the file system performance. This improved performance results from the Unix allocation and free space algorithm, which try to keep a file's data block near the files in node to block to reduce the seek time. So for the performance, even after the basic file system algorithms have been selected, we can still improve performance in several ways. Most disk controllers include local memory to form on an board cache that is large enough to store entire tracks at a time. Once performed, the track is read into a disk cache starting at a sector under the disk head, reducing the latency time. The disk controller then transfers any sector requires than the operating system. Once block is made it from the disk controller into main memory. The operating system may cache the block there. Some systems contain a separate section of main memory for a buffer cache, where blocks are kept under the assumption that they will be used again shortly. We have to illustrate the benefits of the unified buffer cache. Consider the two alternatives for opening and accessing the file. Here we have an example of without unified buffer cache. Here, the read and write system calls go through the buffer cache. The memory mapping call, however, requires using two caches, the page cache and the buffer cache. A memory mapping proceeds by reading a disk blocks from the file system and storing them in buffer cache, because the virtual memory system does not interfere with the buffer cache. The contents of the file in the buffer cache. So for the next example, we have the unified buffer cache. Regardless of whatever we are caching, these blocks or pages, as a result, a system performing many I/O operations use most of the available memory for caching pages. The file system page cache, preventing either from forcing the other out of memory. It changes the algorithms to maximize the use of minimize crashing. This real-world example shows the complexities of performance. We have memory map, I/O using read and write that goes to buffer cache, and the last is the file system.